Start recording, share my screen. And then we're going to go ahead and get started and get through this. We're going to talk about solving and graphing absolute value equations. We're actually going to do more solving than graphing because you've already done graphing absolute value equations, but I'm going to show you what they look like. So on your homework, your quiz, you don't have to graph them. Okay, so you're not graphing at all for this set of homework or quiz, whatever you want to call it. But in the notes, we will graph. And we only have a few questions, and if you need help, just let me know. So remember, if we have this graph, the function y equals absolute value of x, this is the same thing as y equals 1, absolute value of x plus 0 plus 0. That 0, 0 gives you your vertex, and the 1 tells you your slope, and it's positive 1, 1, so it points up. Guys, anytime we have a graph and we're graphing and it is not bound, you need to make sure it has arrows on the end, okay? I'm still getting graphs that are cut off. Eventually, that's going to be counted off for you. So make sure, again, that you're doing this. So make your arrows on either end. So then it just has some little things down here that you need to watch for. It says, for y equals a absolute value x, the value of a determines the width and the direction. So this 1 tells you which way it points. It points up because it's positive, and then how fat it is. If the number gets bigger, so 2, 3, 4, 5, the graph actually skinnies up. It goes towards the y-axis or pulls in towards the y-axis. If it gets smaller, so 1/2, 1/3, 1/4, it starts pulling out and opening up wider. So remember that if a is greater than 1, it becomes steeper. If it's between 0 and 1, it becomes fatter or flatter. So this steeper, sorry, that's not right. It's called a stretch. And this fatter is called a shrink. So it's a stretch because if you think about like Stretch Armstrong or like any kind of like putty or anything, when you pull it, it becomes a lot skinnier. So if you have a big glob of it and it's a big round ball, once you pull it, it becomes like a skinny mess. If you squish it or you pancake it, it becomes flatter. So that's why they call it a shrink. You're pushing it down and shrinking it, which makes it that flat, takes up more surface area kind of deal. Okay. So then there are a couple steps for solving these algebraically, and you'll add another one to solve them for your inequalities. So we'll talk about inequalities later. Step 1 is to isolate the absolute value on the left side of the equation. Step 2 is change to 2 equations and watch out for special cases. And step 3 is solve the equations for the unknown. We're going to do all of those steps, so that's just written there for you to remember, kind of like a cheat sheet. Okay, so we're going to our first question. And our first question says, accurately graph f of x equals x minus 4 and g of x equals 3. Okay, so we have 2 functions that we're going to graph. So when we graph those, somebody tell me how we graph absolute value of x minus 4. Where is the vertex? That's what I want first.
Right 4.
Okay, so from 0, 0, we're just going to move right 4. Sorry, that was left. Right 4. So remember, if it looks like this, the way we get our vertex is we change the sign of the number with x and we keep the last number. So there's your vertex point, 4, 0. Our slope is in the front since we have a 1 in front or no number, so we assume 1 in the front and it's positive. We go up 1 and over 1. And I do want you to stretch these all the way across the graph today. Remember, this is the only time you're graphing is in the notes. So there's your first one. I'm going to change colors and graph my other one. There's no point in you changing colors. I'm just doing it for you visually. How do I graph g of x equals 3? Come on, guys.
We got the x-axis.
Is it the x-axis? Remember, this is the same thing as y equals 3. So what axis should it cross?
The y.
The y-axis. At what number?
3.
3. So this is what it's going to look like when you graph it. When we're solving equations, okay, we're going to move to inequalities tomorrow. When we're solving equations where they cross are going to be your solutions. So where do these cross? What's the coordinate for this? Guys, what is this?
1, 3.
Thank you. Somebody else, what's this coordinate?
7, 3.
7, 3. Thank you both. The 3's don't matter, remember, because we're solving for x. So what are your x's? 1 and 7. So you can do these graphically, but I know, don't take this wrong when I say this. You guys are probably going to be a little bit lazy about that, and that's okay. You don't have to graph, because I'm going to show you how to solve it algebraically, and we're going to get the same answers. So all this is saying is set f of x equal to g of x. So f of x was absolute value of x minus 4. Set that equal to g of x is 3. Okay, I'll slide it up a little bit. Remember that your first step was to get the bars alone, and that's exactly what it's saying. So make sure that there is nothing outside of these absolute value bars. You can have whatever you want inside, you just cannot have anything outside. And on this one, there's not. So we're going to move on to step 2. We're going to set up 2 equations. Those 2 equations come from the fact that if I had the absolute value of -4, I would get 4. Or if I had the absolute value of +4, I would get 4. Okay, so that's why we're setting up 2 equations. So your 2 equations, it's really simple. Take the inside, x minus 4, set it equal to 3. This is a normal equation, no more absolute values. You're going to take that same inside, but you're going to set it equal to -3. So that's your 2 equations. Take that last number. Once you get this absolute value by itself, take the last number and make 2 equations, one positive, one negative. And then you solve. So your third step was to solve. So how do I solve both of these equations? And I do them at the same time because you do the same thing. How do I solve both of these?
We just solve for
Add
x.
the 4 on both of them.
Yep, solve for x, add 4. And again, like I said, I do them both at the same time. You don't have to, it's up to you. This gives me x equals 3 plus 4 is 7. So that's where I got the 7. This one is -3 plus 4, which is 1. That's it. Okay, it's not hard. The only thing people forget is to make 2 equations. Okay, so make sure you make 2 equations. All right, I'm gonna move up. If you need it, let me know and I'll go back. How do I graph number 2? So start with the absolute value. Where is my vertex?
Left 2.
So what is my actual vertex point?
-2, 0.
Perfect. So I'm going to go to -2, 0. And then what's my slope?
-3.
-3/1.
So make sure that we go down. It's pointing down, and this one gets stretched out. So it's going to be a skinnier graph. So down 3/1. And remember, it mirrors itself. So I just put the mirror image. Down 3/1. And I mirrored it. So it looks like this. And see how it got skinnier because it had a 3, and it's upside down because it had a negative. Right, this other one says g of x equals 2. How do I graph that? Remember, it's the same thing as y equals 2.
Horizontal line at 2.
What do you notice?
They don't
They don't touch. No cross. No solution. Okay, no cross, no solution. So there's how you see it graphically. Algebraically, I'm going to show you how to do that. It says set f of x equal to g of x. So our f of x was our absolute value, so -3. Absolute value of x plus 2. We're going to set that equal to 2. Okay. So this is one where we have to get absolute value by itself. There's a -3 outside. How do I get rid of that -3?
Add 3.
Other side.
Do you?
Divide,
Divide by 3. Divide by -3.
Why do you divide?
because it's not adding to the x plus 2, it's multiplying.
Right. So if I had to, which you don't distribute to absolute value, but it's kind of the same deal, this is being multiplied right here. So that's one mistake people make. It's being multiplied, so we need to divide it. So we get the absolute value of x plus 2 is equal to -2/3. Can absolute value ever equal a negative number?
No.
No.
No, this is why this is no solution. So once you get to this point, don't do any more work. If the absolute value is by itself equal to a negative number, then it is no solution. Absolute value cannot equal a negative number. So this one is no solution. Okay, so once you get that absolute value by itself, it has to be by itself, no numbers in front or behind, equal to a negative, you can stop because there's going to be no solution. Okay, everybody good with this one? Now realize when we get to inequalities that may not be the case. So this is just for equations, just for equal to. All right, look at your next one. Where's my vertex for this graph?
0, 1.
Look at it one more time.
-1, 5.
-1, 5. Change the inside, keep the outside. So I'm going to graph that. -1, 1, 2, 3, 4, 5. The reason I'm going over this, I did finish grading your goal 1 test, and some of you were messing up on how to graph and how to move. Those translations are going to be important real soon. Okay, so make sure you know how to do them. What's my slope?
1/2.
So that's up 1 and over 2, and it is right side up because it's positive. Up 1 over 2. See how it fattens it out? It gets a little bit flatter. How do I graph g of x equals 5? Remember, that's the same thing as y equals 5.
It's a horizontal line.
It is a horizontal line at
5.
5. What do you notice on this one?
It crosses at the vertex.
It crosses at the vertex. So how many times does it cross?
2.
Look at it one more time.
Once.
One vertex point, 1 cross. So 1 cross equals 1 solution. So in the very beginning, we had 2 crosses. That gave us 2 solutions. In the second one, we had no cross, no solution. And this one is 1 cross, 1 solution. Those are the 3 different answers that you can have. You can either have 2, 1, or no solution. Okay, so all 3 things could happen, just depends on where it crosses. So now you're going to see what that looks like. So we're going to solve it algebraically. F of x was 1/2, absolute value of x plus 1 plus 5, and we're going to set it equal to g of x, which was 5. Guys, I'm going to write something above this, and we're going to follow the same steps. If I had this equation, 1/2 x plus 5 equals 5. This equation, how would I solve it?
Subtract 5, then divide by 1/2.
I don't divide by 1/2, but we'll talk about that in a minute. You can, that's fine. All right, so this is the same way. Treat this like your x. These are the two things that I need to get rid of. So the first step I'm going to do is subtract 5. That gives me 1/2 absolute value of x plus 1 is equal to 0. That's your key important part right there. Now, instead of dividing by fractions, because that puts a lot on your calculator and a lot in your head, I flip and multiply. So I multiply by 2. Okay, so that gets rid of your fraction. This leaves us with the absolute value of x plus 1 is equal to 0. Now realize 0 is neither positive or negative. So I don't need to make two equations with 0 because I'm just going to have 0 every time. So this is why you only have one solution, because 0 is neither positive or negative, so there's no point in making two answers or two equations. Finish it by subtracting 1, and we get x equals -1. And if you look back over here, remember this point was -1,5. So we got x equals -1 there as well. Okay. We have one more and we'll be done. Real quick lesson today. Okay, if you need more help, remember I'll stay on and I'll do some practice problems with you. I'll just need like a sheet of paper or something. Okay, look at this one. I'm not gonna graph this one. I'm just gonna try to solve it algebraically, okay? You're probably not gonna graph on your test or your quiz or whatever, so I'm not gonna graph this one. I'm just gonna write it. F of x is 2 absolute value x minus 1 minus 1. And g of x is 3. Again, treat this like this equation. 2x minus 1 equals 3. What would I do first to solve it?
Subtract.
Add the one to the other
Add
side.
1.
Add 1 to the other side. Move this one over. So I get 2 absolute value of x minus 1 equals 4. Again, if I were solving this equation, what would be the next step? I got rid of the 1, so now what do I have to do?
Divide by
Divide
2.
the
5 by
2.
2.
Divide by 2. Now, since this is a positive number that is not 0, we are going to have two answers. If we had 0, we would have 1. If we had a negative, we would have none. Okay, everybody realize that. So this should have two answers, okay? Your two answers are going to come from your two equations. The first one is going to be set equal to +2. The second one is going to be equal to -2. Solve them both the same way. How do I solve them?
Add 1.
Add 1 to both sides. And like I said, I do them both at the same time. So we get x equals 2 plus 1 is 3. And then x equals -2 plus 1 is -1. Any questions? All right, I'm going to graph it really quick. How do I graph this? Just to go back over vertices and slopes and what the graph looks like. How do I graph this?
Vertex is 1, -1.
Change the inside, keep the outside. You said the slope was what?
2.
1,
2. You can do 2 over 1. That's fine. It doesn't matter. So which way is this one pointing?
Up.
Up. Yeah, it's pointing up. So 1, -1. The slope is 2, so up 2 over 1. The 2 again makes it skinny. And because it's positive, it's pointing up. And then how do I graph g of x equals 3?
Straight line, a horizontal line at 3.
Perfect. Our two coordinates are -1, 3, this one. And this one is 3, 3. Remember, we only want our x values. So our x values were -1 and 3, just like we found before. Okay. Any questions? All right, I'm gonna stop share and stop recording.